Hello, everyone. If you could just bear with us 1 or 2 more minutes, we're going to wait for other people to join, and then we'll get started. Thank you. As you're just joining, we're waiting just a couple minutes, probably 1 more minute before we get started. Thanks for your patience as others continue to join. Okay, Rachel, let's go ahead. All right, folks, what a way to start our time together. Thank you for joining our session on how to teach a new dog old tricks, the value of dynamic sensing with Spot. Good afternoon, good morning, or good evening, depending on where you're at or connecting from. We're just thankful that you're here. My name is Ray Michek, and I'm one of the partners at Aquitas. I'm going to be your host for today's hour-long session. So first, a couple of housekeeping items. The session is being recorded and it will be distributed to you along with the slides after the session. Now, I'd like to give a special shout out to Young Jong Lee, who woke up at 3 o'clock this morning in South Korea, who might have got a little bit more sleep if she knew that it was being recorded. So Rachel will need to make sure that we put that in future notes. Any event, please stay on mute. If you have a question, enter it into the QA pane on the right-hand, I think it's on the right-hand side for you guys. And we'll do the best to answer those questions at the end of the session. Rachel, as I mentioned, will be assisting in the background, running our slides and helping to monitor our chat. And one final thing, I just say, please stay with us because we will be showing Spot live in action. A lot of times you have these discussions and you don't get to see what you really came to see, but that's probably what you wanted to see. So stick around, we're gonna do that. And at the end, not the end of the session, but that's how we're gonna wrap things up. All right, let's dig into the agenda on what we're gonna cover. All right, we're gonna do some introductions, and then what will happen is we'll talk about the business challenges and why Aquitas is investing in Spot and why we're so excited about this, this platform. Next, we'll do a practical value discussion with Nicholas Despain. Then Paul Cisternelli is going to talk about the Spot platform and use cases and kind of clarify things a little bit. And then Will Jones from Boston Dynamics will, of course, show us Spot in action, then we'll wrap up with questions and answers. Thank you for joining, Will, Nicholas. All right. Okay, that's a good thing to do. Let's start with introductions, if we will. So we've got a great panel here with us. I've been working in Maximo now since 1997. So a couple of these guys, you'll be able to guess, the ones with gray hair. Although, Paul, that's a really good picture of you, so I can't tell if you have gray hair, that I've known for over 20 years. Paul Cisternelli, who runs enterprise sales, the enterprise channel sales for Boston Dynamics. Not only does he have 10 plus years of mobility experience with Samsung, yes, even BlackBerry, which is really cool. He and I worked together at MRO Software back in the day for about 5 years. Nicholas Despain has nearly over 35 years of process manufacturing experience with companies like Frito-Lay, Dannon, Nestle, and he's probably one of the most tenured. You are, Nicholas, go ahead and say it. You are the most tenured Maximo person I know in the ecosystem. Now, before joining Aquitas as our Director of Manufacturing Solutions, Nicholas implemented Maximo in 10 different sites for a company called Leprino Foods. So he's going to be talking about it from a customer perspective. And then Will Jones, well, Will's a little bit newer to me. Hey, Will, thanks for joining. Now, I just really recently met him. He's one of the account managers at Boston Dynamics, but he has a prior background as a nuclear physicist. Is that right? Wait, I think it's nuclear engineer, but same thing. Takes a lot of brains to do that stuff. And so you bring a lot of smarts to the table, and you'll be leading our demo today. So thank you for that. All right, so let's dig in here. First, Rachel, I'd like to do a quick poll. Oh, hey, how about this? We'll tell a little bit about Aquitas. I forgot to say that. We were founded in 2006. We've got over 250 customers across all different industries, very well known within the Maximo ecosystem. Love the brands and the companies that we work with. And we've got a host of Maximo and IoT award-winning implementations that we've been involved and engaged in. So thank you, Rachel. I would have missed that if you didn't bring that slide up. Okay, now let's do a poll if we could. All right, do you use robotics at your plant or facility? If you could just click in that. Again, it's a simple question, doesn't mean for maintenance, just means, do you use any robotics at your facility? Rachel, give us a time frame and then bring up the results.
Go for about 15 more seconds.
It's not too hard to click yes, no, or not sure. We made it easy for you. All right, let's see what we got. All right, so 30% of the people use robotics in some form at their facilities, 61% no, and 11% are not sure. I remember just walking through various Maximo customers and seeing little robots, and I think they were singing the theme from Raiders of the Lost Ark, and they were carrying products from one side of the warehouse to the other. So it's interesting how it's proliferated. Those robotics can be on the plant floor manufacturing things. Okay, so let's go into a couple of other things. I want to talk about why Aquitas is so interested in this platform. So over the past 10 years since I joined Aquitas, and even more so in the past 3 years, we've seen these 4 trends kind of manifest itself. There's a shortage of available resources at the plant or the facility necessary to do maintenance work. There's this great resignation. We're losing skilled workers. We always talk about the aging workforce leaving. And how do this need in these maintenance and reliability organizations of how do they attract good workers? Then there's the training of new workers that do that needs training the new workers to do the work that needs to be done and documenting that information. And then the third piece is these legacy assets that we want information off of, but don't have sensors, but still need inspections. And it kind of all works together because you need people to do those inspections. So this prompted us very early on and to explore and deliver IoT solutions. Though when we started, it really wasn't called that. It was just called integration. And the goal was to help customers address some of the challenges we just mentioned. Is how do we use those technologies to address those things? And the goal has really been the same since the beginning, since I worked on Maximo. Nicholas, maybe the same for you, is that how do we get plant or facility asset information into Maximo for action and future decision making or planning, proactive condition monitoring, if you will. I mean, it's nothing new, but it's the ability to get that information over. So for the past 5 years, we've been focused on how to help our customers get more out of Maximo implementations by leveraging technologies that we group into what we call connected maintenance. Next slide would be great. All right, so what we did, we took a look at these solutions, and Maximo's kind of the foundation, and then what are the things that are additive to help you get more out of that? So we had sensors, we had connectivity, move information back and forth, we had platforms that help take that information, contextualize it, and move it around, and then augmented reality that would help with both kind of understanding the operating of the asset and kind of help with training, smart connected products, and workplace health and safety. We've created these solutions for our customers. And I think the question would be here is, but why Spot? Click one ahead, Rachel. And our friend should appear. There's our friend. That's better. All right, it took a little while to come to the forefront. The question, but why was Spot? What we found was the biggest challenge was not really the software to analyze the information, or Maximo wasn't an issue. It was getting the right information and really just the right amount of information we need to Maximo, so for action and analytics, if you will. And the path to newer equipment, Nicholas, I'd say it was pretty easy. They were censored when they came right out of the factory door, but these factories, some of them have been around 30, 40, 50 years with legacy equipment that was out there, wasn't censored. And then there was all this stuff that had inspections that were manual and things that had to be done. And what we found was that there was this connectivity gap that existed. So at Maximo World last year, Spot made an appearance. I'm not sure who was at Maximo World or not, but what was exciting was Spot came out, did a dance, Paul gave a presentation, and as I sat there, it was cool and neat. I started to look past the wow and saw it as a platform to fill the connectivity gap. So hit one slide, one section of, there you go. All right, so we saw that as a way to fill that connectivity gap as a platform. And we met with Paul and his leadership team from Boston Dynamics to discuss the practical use cases around Spot as it relates to maintenance and reliability. We had a chance to validate that with Skip Snyder, who's a senior partner at IBM, leading their global connected operations practice. And he talked about their grand plans for where Spot fits into overall maintenance and reliability of operations, big implementation. And we had to agree that this was something that we had to take a look at, invest in, and help our customers move forward, because we saw it as a solution to some of those problems that we discussed. So I remember sitting with Nicholas, and we were there watching. Nicholas, you and I were close together, and we're looking at the stage, and we're seeing it. And I turned over to you and kind of smiled, and I said, "What do you think?" And what? Maybe you just tell me a little bit about your initial reaction there.
Well, I'll tell you what, from working in the manufacturing environment for so long, when I first saw that, I thought, wow, what a cool toy. That looks like a lot of fun.
Yeah.
But there's no way it can work in manufacturing. It's a toy. That was my first reaction. It's a toy.
I remember. I said, but it's really, and you go, yeah. And I think that it's sometimes, and look, we've seen Spot all over the place, right? It was in the Super Bowl ads. I saw it in a Katy Perry video. Sorry, I admit that I watched the Katy Perry video, basketball games, weddings. But what kind of changed your mind? What flipped the script, if you will?
Well, remember at first he's dancing all the place, and we don't do a lot of dancing in manufacturing, but we do other things. So between the first time I saw Spot and the second time during those 6 months, I talked to a lot of people and realized that things have gotten worse since I left manufacturing. When I left, we were down about 5%. And now with the Great Resignation, you're talking up to 20% of people not being available to help us with our technical aspects. So my first thought is—
Wait. Just to put that in context, 5%, part of me said, 5%. What did that mean across your 10 plants in terms of actual people?
depending upon the size of the plant, it could be anywhere from 2 to 20 plus mechanics short of what we need to run per plant on that. So a significant number of people. Plus, when we're getting them, they're not always technically trained to go there. So it takes time to get them up to speed. So the shortage was even worse. It's gotten worse. So my first reaction, just like on the slide, is we need more connective maintenance. We need to be able to get those sensors and get that information, get that automatic meter reading available to us. And then I remembered one time in one of my older facilities, we wanted to connect the perimeter cameras and sensors, so increase our security. And the quote was over $100,000 just to wire up those things. And that's when it kind of hit me going, wait a minute, Spot doesn't need to be wired. We could go around all those places and or look at meters, do meter readings, do sensors, do things. So all of a sudden it's an opportunity here. What if we used Spot instead of hardwiring the entire factory, use Spot to go around and find all, get all those sensors and get all that data? That is a potential cost savings. It would save us money and still get us the information we need to be effective.
Yeah, that's interesting because, you know, I think the first reaction kind of follows that pattern, right? It's a cool toy, and then you start thinking, well, look how sophisticated it is. It has to be really expensive. And then you kind of came to the conclusion, wait a second, there, from an implementation standpoint, it's could be a wash or less to implement this versus, you know, actually going through and hardwiring. So that's a interesting take on it.
In some cases, it could be a cost savings on there. And so the practical side of this is not only a cost savings, but once you have it in there, I see real value in emergency situations when we had ammonia leaks to send Spot in instead of a person in there. That it's always a risk when you do those kind of things. And then of course, there's the coolness factor on there. It's a really cool device that requires some technical side of things. It would attract a younger generation in manufacturing that we're short, and getting them into manufacturing, doing a cool toy, but also dealing with something that is a cost savings. That labor that we save can be redirected into so many other things and get so many other things done that otherwise we just don't get done because we don't have the people to do it.
Yeah, 2 points. So we'll use Will as an example. Here's a guy working in the nuclear industry, pretty sophisticated, cool stuff. Yet it's the, you know, in talking to him, and Will, you can let me know this when we go to your section, but hey, it was kind of the coolness factor that attracted him to go work for Boston Dynamics. So it's the same concept. It's as you introduce these new tools to the people that are doing the work, as those old guard kind of goes out, you know, the people with still flip phones, not that there's anything wrong with that. You have to get that video age people coming in and say, hey, this is a worthwhile career. I think it's an excellent example. Now, you've always been a proponent of, again, taking out kind of those standard PMs and rounds and inspections, if you can automate those in order to redirect people. And I don't know if you have any other comment on that.
Well, this is a opportunity that at first I didn't see right away. I saw it as a toy. But in some of those legacy older facilities that I work with, I mean, it's one thing in a greenfield, you get to wire things up and get everything done correctly, but it's still expensive to do. What if you could do it without all that expense? Now all of a sudden it's not a toy, it's a practical solution for a manufacturing environment that needs help. And we need to improve our reliability so we can get more product out the door with less resources.
Yeah, good points from a manufacturing standpoint, practical applications. All right, thanks, Nicholas, for joining. What we're going to do is kind of move it forward just a little bit. Stay on the line because there might be some Q&A things that we want you to address. Now, let's do another poll. Which of the following is the most pressing challenge at your facility? Is it a worker shortage? Is it losing skilled workers and attracting new workers? Is it training new workers? Or is it legacy assets needing inspections but no connectivity? So go ahead and we'll give you about 30 seconds to do that. Rachel, I always say that this is where we need the music playing so that we can make it a little bit more pleasing. We'll work on that for the future presentations. All right, 5 seconds. All right, Rachel, let's see what the results are. Oh, kind of well spread out there. I like I don't like it. It just kind of speaks to that, is attracting new workers is tough. And then this legacy of inspections with no connectivity, I think that is highly revealing. Okay, so let's get the presentation back up there, if you would, Rachel. And what I'd like to do is turn it over to you, Paul, with all of this information as a backdrop, give us a little context here, take us through Spot as a platform and use cases. Welcome, Paul.
Thanks. This is terrific. And the poll was very insightful to what my presentation is all about, because when you start looking at Spot, what's the value proposition? It's really going to try to address these couple of points for us. So yeah, Rachel, let's move ahead. Again, I just want to give you a quick overview of Boston Dynamics and who we are. A lot of people think of Boston Dynamics, they think of, you know, my cousin Vinny from Boston. And that's one thing we do. We do a lot of those kind of cool videos, as you can imagine, just to show off the capabilities and the dexterity of the robots. That's one of the reasons why we do this. So Rachel, we'll move on to the next slide. The mission of Boston Dynamics, and I like putting this up there because a lot of people understand, what are we all about? Are we just trying to go out there and build inspection modules and things like that? That's not what we're about. Our company, Boston Dynamics, is really geared towards the concept of leveraging robotics and making them to the point where they truly enrich people's lives. So really what that means is it's all about an R&D effort. Our focus is literally on the mobility and athleticism of the robot itself. As we continue down that path and making that more and more mobile, the ability to add functionality on top of the robot just continues to expand, and that's what we're going to focus on today. So next slide, Rachel. Let me just kind of introduce you to the portfolio of robots that we actually have at Boston Dynamics, and there's actually 3 in there. You can go to the next slide. There's 3 in there right now, but we'll continue to augment this as we move forward, and I'll just introduce you to the kind of the starting lineup here. So on the right-hand side is our Atlas platform. You've probably seen Atlas at the carrying the Sam Adams keg, or doing a dance on YouTube, or doing a lot of different things. It is a biped robot. It's a humanoid robot that is geared towards our engineering and our research and development teams as kind of their green field. When they come to work every day, they get to play with this humanoid robot. Pretty good job. It attracts folks from the type of colleges and universities you might imagine, because they get to work on this robot every single day. And the purpose of their efforts is to determine, to really kick the leading edge of the electronics, the materials, the batteries, the software that goes into designing a robot that has capabilities to maneuver. Now, that robot is not a commercial product. It is strictly an R&D product, but a lot of the technology that goes into Atlas finds its way into our 2 commercial products. And the first one that I want to talk about is Stretch, which is the one in the middle. Stretch was introduced in 2021 as a new product for warehouse automation. And it's very simple. It looks just as you can see there. It picks up boxes and it puts down boxes, and it will do that all day long. So if you've ever been to a Amazon facility or huge Walmart type of facility where they have, 300 truck bays, and the trucks pull up and each one of them are filled up, and they put an army of people in there to move these boxes to pallets and things like that. So Stretch will do that more effectively, faster, and at a less cost than your labor force. So that's what Stretch is all about. It's really going to become the market in 2023 as a commercialized product. So we'll see a lot more of Stretch moving ahead. And then finally, Spot, which is our quadruped robot, which is the one we're going to focus on today, and how it is revolutionizing a number of different industries. But we're going to focus on its ability, its focus in terms of mobility, and then the platform that it enables. So next slide, Rachel. I like to throw this slide up. This is from a friend of mine over at ARC, but basically this is something that everybody on this call and most of the maintenance management, industrial management companies that I've worked with in the past, the real goal here is to continue a process to go from very reactive to preventive to a predictive analysis. So the further I get along this trajectory to a predictive analysis, the more cost savings that I'm going to enjoy, the higher efficiency of my assets, all of that's going to come through. So the ROI is going to increase over time. We all understand that. This is not an easy task for us, though, to move from reactionary to preventive to predictive. So that's the goal. And then the next slide, Rachel. The challenge with going along that is really not about robotics, but it's about data. And frankly, it's about the lack of data, right? I can't capture the data. I can't analyze the data. And once I get the analysis data, I can't make decisions based on that data. That's the issue at hand. The more data I have, perhaps the better. But
Paul, what we found was it's hard to analyze job done. There's not much analytics that comes from that. That's why it's so exciting. Yep, sorry about that.
No worries. Well, what I found is a lot of times we get data and all we're doing is really pushing down the problem, right? Because now we got too much data, it's turning the fire hose on and I can't analyze the data. So you really have to have this supply chain of data. And what we're going to talk about is how to Spot address this challenge. So the next slide, which is what we'll return as the solution, which is something we're calling dynamic sensing. And it's really a simple, marketing term that talks about this concept, and Nicholas talked about this, where in many factories and facilities that are traditional or legacy based, the ability to go out there and retrofit these facilities with fixed sensors throughout on perhaps thousands of different assets would be just cost prohibitive and time consuming, right? And then you'd still have the problem, well, now we're just capturing more data. So the concept of what people do today is they hire some people, the people they can't hire anymore, or they take one of their very high value mechanics or engineers to do these jobs with a clipboard and go around and do these inspection routes to capture the data. Neither one of those options are very viable anymore. So what can I do? How do I automate the process of capturing data, doing those inspections, gathering the data, and then processing that data? And that's what dynamic sensing is all about. So next slide, let me talk a little bit more about this. Next slide again, Rachel. When we talk about Spot, we're going to start looking at all these different types of use cases that kind of emerge. And people ask me, what does Spot do? Well, Spot is a robot that walks around and will get from point A to point B very efficiently. That's really what it does. What our partners do and what we do is enable solutions that reside on top of Spot, that requires a vehicle to take the solution to a particular area. And all of these different use cases, and this is just a sampling. Nicholas mentioned ammonia detection, gas leak detection. The canary in a coal mine. We send the robot into the mine first to see if there's any gases in there before we send our humans in there. So all of these types of use cases started emerging all because they were enabled by the mobility of Spot. So the next slide, Rachel. And this is kind of what the inspection looks like if you wanted to really look at Spot in a real classic world. You see the Spot robot there, and then behind it is a docking station. And the docking station serves two purposes. One, it recharges the robot, like you might see your Roomba going back to its port to recharge. This will do that also, find its way home. But it also has a large Ethernet port, so we can upload all this data to your backend system anytime it wants. But in addition to that, what you see on the front is what we call our SpotCam payload. And that payload is a very sophisticated stack of payloads. The bottom half is a 360-degree video capture camera. So as it's walking around, it's taking live feeds of what you see. On top of that is a pan-tilt zoom camera with a 30 optical zoom lens that will, once you get to something, you might want to take a quick reading of an analog gauge, a pressure reading. You may want to take a quick zoom in image of a well that looks like it's giving way on a steam valve. You may want to look at any type of corrosion that's taking place. All of that can be done with that pan-tilt zoom camera. And then on top of that is an infrared camera that as you're making your ways around and you stop in front of the motor, you may want to take a reading to say, what's the temperature range of this motor at this current time? And is it in tolerance? So all of that's done through the Spot Cam, and you'll see that there's actually a microphone boom on there also to take acoustic readings or any sound analysis. Because when you actually have these workers who have been around for 30 years doing these inspections, one of the value propositions of them is this content knowledge that they have. They walk around, they can smell it, they can see it, they can just listen to it, and they go, something's wrong here, right? You can't teach an old dog those types of tricks overnight, for example. But Spot's going to go a long way. So next slide, Rachel. I'm going to just give you a couple examples of some key customers using this. And again, if you want to look at Spot has about 1,000 robots out in the field today. So 1,000 different types of companies using Spot, some using multiple Spots, obviously, but it stretches the gamut from industrial world in terms of both discrete and process manufacturing, energy in terms of the utilities, substations, oil and gas, in security and surveillance type of operations. Think in terms of Spot walking around the perimeter of the fence to determine if there are any breaks in. And then construction world also, where we're working with companies like Trimble and Farrow. We're doing 3D diagnostic scanning of industrial sites to see if we're on track. So a lot of different ones, but I'm going to just talk about 4 quick ones here. National Grid, which uses the thermal camera in their substations outside. They actually go there, take quick readings of every one of the bushings and the insulating plates below the bushings. And when this facility is running, it's just not safe to be there. So they're doing this using Spot to walk these facilities while the plant's running, so I don't have to shut down, to gauge this readings to determine, are my bushings running hot or cold? On the right-hand side is OPPG, which is using multiple Spots. They're actually into radiation detection and mapping for some of their nuclear sites, where we actually have Spot, which can absorb radioactivity. So instead of sending other vehicles and other people in there saying what's the absorption rate of the radiation, you can have Spot do this detections for you. And then once it's in there, it can do those inspection routes over and over again. Down below, we talked about Woodside, which is a large natural gas company based in Australia. They're actually using a fleet of robots. And the neat thing about them is they might send a robot around on the initial mission pass or the inspection, and based on the analysis and data captured from that initial pass, let's say the initial pass is just capturing imagery, photographs or video, and based on the analysis of that, they may say, okay, we suspect that something's wrong at this level. So a second robot might get up and go to that level and start doing vibration analysis or infrared technologies. And then based on that, they may send a different. So they actually have a fleet of robots working in harmony together to do these inspections. And then finally, Kidd Mining, I kind of alluded to this, but Kidd Mining is very large nickel mining up in Canada. And they made it very clear to us, listen, every time we do any explosive activity within the facility, by rule, they have to do an analysis of both structural, is it safe to send people in there, and gas, right? Is it safe to go back in there? So before they can send any crew in there, they have to determine this. Well, how do they determine that, right? They can try to send a drone in there, it hits the wall, it hits the ceiling. It's very hard to fly a drone down a mine shaft. They can suit somebody up in a complete hazard suit and send that person in there. I don't know, but that's not the job that I'm looking for. But what was really kind of interesting, they said, we used to do this with wheeled robots, little wheeled robots that looked really cool, but they would get halfway down the thing and they'd hit a rock and get stuck. So you know what they did? They had to send a person in a truck with a front load plow to clear the road so they could send the robot in to see if it was safe. A little strange. They saw Spot, send Spot down there, it comes back out, it's the canary in the coal mine without killing the canary. Next slide, Rachel. And the next slide after this also, Rachel. So I'm going to talk about 2 things about Spot before I hand it over to Will. First, I'd like to talk about the athleticism. And if you could run the video in the upper left-hand corner, Rachel. I'm going to talk a little bit about the athleticism of the robot. What can it do? And this is really where the focus of Spot is all about. It can walk up and down stairs by itself. And that's not an easy thing to do for a robot, if you think about it. It needs to understand what's the size of the riser, what's the depth of the riser, is it a metal riser, is it a graded staircase? It needs to know where the banisters are so that I know where to step and go up and down stairs. Comes in a lot of handy. And then the lower left-hand side, if we can run that
Hey,
video.
Paul, I was going to say, getting older, I'm having trouble going upstairs, let alone, figuring all that stuff.
Those payload, that's right. And this is definitely, I could not make it up this, but think in terms of the robot now not walking up a thick staircase, but a set of loose gravel where each one of these rocks are giving way underneath its paws, and we're going to show how the robot automatically self-balances itself. Very sophisticated mobility. And then the upper right-hand corner shows you an example of what we call the obstacle avoidance. So Spot has 360-degree cameras all around it, and as it's kind of makes its way through these fire doors, it's not only going through a very narrow door and avoiding the sides, but it's also stepping over the thresholds. So that's all done with its onboard cameras. And then the final one down below is kind of just a fun one. If you really find an obstacle in front of you, like a door, what do? Well, Spot has a manipulation arm, we call it the gripper, that basically understands how to open doors. So it knows, hey, this is a doorknob, the doorknob's round, I turn it to the right, then I push and pull to see if that door goes in or out. I realize it comes back, so I put my left paw behind the door to keep it ajar. I open the door, and then I walk through. So that's a little bit of sophistication about how the robot has athleticism. So now how do I take that athleticism and make it valuable to a manufacturing site, a security element, things like that. So next slide, please. So this is the second part of Spot. And really, this is actually probably the more important part of Spot. It's not as much fun to look at, not as much fun to watch, but this is where the rubber meets the road. This is where the ROI is delivered. Spot has an API platform that allows partners and customers to build customized solutions on top of it. And these are very important because it's not just a box that sits on top of Spot, it's a means of communicating to the robot itself. And it comes in three key areas that I'll talk about. On the left-hand side is the data capture. This is exactly what we're seeing. Can I go around and capture data? Depends on the data I need, right? Images, temperature, audio, laser scans, etc., gas detections. Those types of platforms are basically the dynamic sensing. Can I take sensors that I need to capture information, have it communicate to the robot, and then use that information as we move forward? Once I've captured information, the next part is the data analysis. I'm going to turn data into information. And really what we've done there is we have a lot of partners using very sophisticated AI conversions and computer vision models that say, hey, we've just taken a picture, and this is what it's supposed to look like. So if I can compare what it is and what it was supposed to look like, I can do an anomaly detection. And that's all the type of analysis, or a temperature reading. Is it in range or is it out of range? Those types of things. Once I do that anomaly detection and detect that something is wrong and requires action, then it comes to the third part, which is an integration to back-end platforms like Maximum, like SAP, like Oracle systems, or even a little simple. Maybe I just send an alert to the mechanic sitting on the floor to his cell phone saying, hey, go take a look at this. So this platform, Spot as a system, shows not only the athleticism of the robot, but the solution that we're going to deliver. So next slide, Rachel. So just kind of wrapping up the why Spot. Transformative mobility like you've never seen before. You've seen me at any of these conferences, and if you haven't, come see us. I'm up in Boston area. I'd love to take you for a tour of the room right behind me where Spot lives. And Ray spent some time up here a few weeks ago, and love to have you up there anytime you want. Flexible platform that I just talked about, and that's the platform where we build up the solutions. This autonomous inspection, and there's really two kinds. There's autonomous inspection, the robot goes around by itself and captures data. And then there's remote inspections, right? Where, your facility is 200 miles away and something happens. What do? Do you get in your pickup truck at 3 o'clock in the morning and drive out there to check on that gas leak? Or do you log in through the browser and fire up Spot and say, hey, go take a look at this for me? That's remote inspection, and Will's going to show you that. And then the key ROI is easy. Safety, efficiency, predictability. You take those three, you plug in your ROI for Spot, and you're going to see not only is it paying for itself, it is adding to your bottom. So with that, I'm going to turn it over to Will for a quick demonstration, and then we'll be back for questions and answers.
Awesome. Thank you, Paul. So I will share my screen.
It's always the tricky part, Will, right here. This is where it all comes together.
Okay. Yes. Okay. Just need to make sure that, okay, you are seeing my control screen, correct?
Yes. Yeah, tell the people what they're seeing so they understand.
Perfect. So this right here is our Scout platform. So essentially what this allows you to do is drive Spot through a web browser. And what's the benefit of that? Benefit of that is that basically what Paul alluded to, what he just said, if you've got a remote location that's about 200 miles away, rather than having to roll trucks to go there, you can now access Spot through the internet to be able to drive Spot to get situational awareness. So it really allows you to drive it from the other side. Oh, there's Paul. Allows you to drive it, say, from the other side of the building, which is what I'm doing right now, the other side of the country, or even the other side of the world, wherever you have internet connectivity. But I'm going to do a few things here and drive Spot. So I just clicked here in the screen, and as you can see, Spot is moving. I can also use the keyboard. So the W, A, S, and D keys, if you've ever played a computer game, that's probably very familiar. And you can move Spot all around. You can also get situational awareness by cycling through the camera views here. And as you see, I'm going to look at the back. So this is looking at the back of the
That's
robot.
good, Will. So that we, it's not Paul taking a camera around directing them. They can actually see Spot walking.
Exactly. And what we'll do here is we'll just show Spot walking around a little bit here, so you can see that Spot actually really is truly moving. And what I'm going to do also is just have Spot go over these rock boxes over here. So we're going to line Spot up, and I'm just going to use my touch to go feature, and we're just going to have Spot go over towards these windows, and you'll see Spot navigates right up and over these rock boxes and makes its way to the location. So as you can see, Spot very, very easy to use using this platform. So we'll do the same thing going forwards. So now I'm going to press over here over these rock boxes, and Spot just navigates its way over any sort of obstacles. So I'm going to go right over here, and Spot's going to go over that grate. So if we look in the back right here, we see that Spot just went over that grate right there. So the nice part about Scout is that it allows you to adjust many of the parameters of Spot. So you can turn off the obstacle avoidance, you can adjust the obstacle avoidance sliders, you can adjust the speed of Spot. It also has the stairs mode, and then self-righting. Anything with legs will fall. So we have the ability here to have Spot self-right itself if it ever does fall. You can also adjust things such as height, tilt, and some other detailed ground friction characteristics. You have the ability here to transfer missions back and forth between Scout and between the robot. So that way Spot can run autonomous missions directly from Scout. You also have the ability to control the payload that is on top of Spot as well, such as the lights, audio, and then if there was a thermal camera, you could turn on the thermal camera as well. So with this, we'll do some stairs. So I'm going to turn it into stairs mode using the slider over here on the left, and then I'm going to bring it over to these stairs over here, and then just take it up the stairs. So stairs mode gives Spot a little more understanding that it's actually on stairs. So it understands the edges a little bit better, how deep the stairs are. It keeps Spot centered in the stairs, adjusts Spot's speed and angle on the stairs to make it go much more reliably up the stairs. So we'll just send it right up. And all I'm doing right now is just pressing the W key forward, and Spot is doing everything else. So I am only pressing W, Spot is doing everything else. So I'll turn it, and we're going to go up So just imagine that we are in an industrial facility right now, and you need to get situational awareness on some assets that you need to climb up on top of these catwalks through all kinds of stairs and things like that. So these are some very real applications that we see our customers interested in.
It's really like a little bit like the Tesla of robotics, is that,
yes,
you're kind of in control, but you can let it be on its own control to navigate. Really cool stuff.
and then so from here, so right now I'm in driving mode, which you'll see right up here. I'm going to switch it to inspecting mode. So what inspecting mode does is we now are using the 30 times optical zoom pan tilt zoom camera. So we're going to zoom right here, right into Paul, and you can see that he just picked up that Hershey's bar right there. But this right here gives you a good understanding of how detailed of an inspection you could do. So if you did need to look at a gauge or an asset or a weld, you absolutely could do that. And then you can press these little buttons around here, and you can move. So we can zoom in a little bit more to really get a better understanding. And maybe you can see the nutrients facts on the Snickers bar if you're interested in that.
Yeah, we see that there's one Hershey's missing that Paul took.
Paul definitely took that one. But as you can see, you can do some very detailed inspections using this feature here. You can also, there's a button right down here in the bottom left-hand corner. I'll click that, and that allows you to take a screenshot of whatever you were just inspecting. So say there was an issue and you need to record that, you can take a screenshot of that and say, here's the issue that needs to be fixed. So
hey, Will, is that using an accessory camera, or is that the camera that's built into Spot that it uses to navigate?
So these are a payload camera, so essentially an accessory camera. So
okay.
The way that Spot drives is it uses these onboard cameras that you can see here. So these are looking through Spot's onboard cameras. That's what Spot uses to navigate. But in order to get some detailed inspections, that's when we switch to the camera that's on top of Spot. It was the big black camera that was on top of Spot, and that's what it uses. So now we're going to rotate it around. We're going to continue walking over here, and we're going to bring it back down to the ground floor. So I'm using my WASD keys to navigate Spot around, and then we're going to bring it down these stairs over here. So the way that Spot's legs are designed, it walks more reliably downstairs backwards. So that's why I'm rotating Spot around. We have it lined up to go down backwards. We're still in stairs mode, and then I'm just hitting the S key to walk Spot downstairs backwards, and Spot is now doing all of this on its own. All I have to do is just say go down the stairs, and Spot figures out everything else on how to navigate those stairs. So we will put the front camera again, and then we will navigate Spot around. This is actually a perfect spot right here. So if I go to the Spot cam, you can turn the lights on. As you can see on those reflectors, that now shows that the lights are on. So say if you're in a really dark area, you can use the lights to help turn those on. So one other thing that is very valuable about Scout is we're going to look at the session history. So this here allows you to review the data that you captured from your mission. So we will look at this mission here, and we'll look at this action here. And what this does is it allows you to, every single time this mission was ran, you can see the picture of that asset or whatever you took an image capture of. So you can see how over time, how that asset changed, and then you can very quickly and easily identify if there's an issue or anomaly. And you can do that with any sort of actions that you have in your mission. Another thing you can do is you can schedule missions. So we will go to missions right here, and this allows you to schedule a mission if you want a mission to run at a certain time, certain frequency, and on a certain basis. So you can choose a robot, so you can have multiple robots within this platform. You can choose which route, which mission you want it to do, which inspection round. You can choose right there, you can see a date and time, and then you can also have it repeat every frequency. So if you wanted to repeat every hour, every 3 hours, every day, once a week, you can set that here, and you can have that mission replayed there. And then we'll also look at this alert feature here. So you can see here where Scout can now send you email alerts if it finds something that's an issue. So you can program this such that if there is a condition that needs attention, Scout can automatically email. And with that, I think we will probably hand it over for questions.
Hey, Will, before you leave, can you have Spot back up there for a second? So, you know, there's always people who go, well, that was probably recorded. Or so we were going to hold up the today's edition of the Boston Globe, but nobody gets the paper anymore. So why don't we have it walk over to the resting spot and then turn back to one of those cones?
Yeah, absolutely.
Not too difficult to do. There you go.
Absolutely, yeah. We're just turning Spot right around right now, and then I'm going to I'll click over here, and it is walking all on its own. Here, I'm gonna put it right through the back camera, and you can see. So I put it through the back camera, and then Spot decided that the most efficient way to get there was simply just to walk backwards.
Yeah, we did have, Paul was wearing the same shirt when he went to go get the Hershey bar, so at least we planned that correct. All right, hey, Will, thanks so much. I think we'll go to Q&A now. You know, there was a couple of questions that came in the chat. If you have any, I know there was one is what is Spot? So hopefully you guys, Nicholas, you can come back on camera. I'm not sure if there's going to be any questions for you or not, but we'll put them out there. You know, what is Spot? That was the question, and you answered that. It's a platform that allows you to bring those instruments, if you will, to the asset. Dynamic sensing. I love that, Paul. It's a great term. So one of the questions that also came through was, what is the battery life of Spot? That should be an easy one to answer.
Yeah. Sure. The battery life is approximately 90 minutes on a single charge. So the robot will get up, it will do its thing, it will take advantage of the long mission for about 90 minutes. Now, I do caveat that by saying the more you put on Spot, because everything that goes on Spot is also drawing from the same battery charge. So you may lose some efficiency, but that, you know, target 90 minutes, and it will go back to its either its docking station, and we'll get about an 80% charge relatively quickly, just like most batteries do, and be able to come up and start driving around again. When people purchase Spot, they get 2 batteries and a remote charger. So typically what happens is you're always charging. So you can do a quick swap out of the battery and then continue working with Spot. So 90 minutes on a single battery charge, you swap out the battery, the old battery goes into the charger and continue working.
That's great. And Nicholas, I would imagine that 90 minutes is enough to do a round or an inspection. Of course, it sometimes takes a person a little bit longer because they get waylaid and they get tugged on to do other stuff while they're doing their round. So that seems reasonable, and I would take it from a plant perspective, correct?
Yeah, and also the ability to do it anytime. I mean, that's one of the biggest advantages. You can time this and schedule this during breaks or lunches or sanitation times or cleaning times so that it's your most productive.
All right. Another question that came in, have you got anyone undertaking asset information collection tasks and pushing this data into Maximo, and can it generate 3D models to push into Forge? That might be a little bit too specific, but using it for data collection and 3D models. I think you alluded to a little bit that, Paul.
Yeah, no, matter of fact, IBM's services organization, Skip Snyder, who you mentioned earlier, are doing a lot of work with computer vision models. So they actually use the robot, and they're doing this with National Grid. They're using the robot to go around and capture computer vision models as the first part. So what that actually does, it starts building a portfolio of comparison charts, right? So the bigger your computer vision model portfolio is, the more accurate you're going to be in terms of determining anomalies. So once you have this large portfolio of computer vision models, now when you go around and do the actual inspection, you're comparing that inspection against a very large portfolio of images. And based on what it sees and which one matches up the best, it will take the appropriate action. And I like to say that because if it finds one, hey, it took a picture and it's comparing it against this, and hey, this thing is on fire. What does it do? Well, it will keep call 911 or something, right? If it just says, hey, this looks like it's rusting a little bit, add it to the next maximum downtime outage schedule that we might have. So it all depends on what it is.
And so again, the APIs, just like anything, is once you get the image or data, you use the same. If you were going out collecting it without Spot, you would use those similar APIs to get that back into Maximo or what other software that you would use. All right, another question. This one's realistic. It says, can Spot work in other areas with humans and other robots?
Does it play nice in the sandbox?
Yeah.
It can. It has an obstacle avoidance. So it's not like it avoids human, it avoids obstacles. So you've seen it at trade shows, and people kind of walk up to it, and it will automatically stop when it sees an obstacle or try to walk around it. So it won't walk into you. So it will work in an environment where there's people. The more people, the less the robot's going to do, because it's going to start saying there's too many obstacles to do anything. But I will share a very good example of a very large company that I can't share the name with, but they tend to make alcoholic beverages. I'll leave it at that. They have a warehouse where they've actually used automated forklifts, right? So there's forklifts going up and down these aisles, automated. And now you have an automated forklift and you have Spot walking down a perpendicular one at the crosswalk. So neither one of these two robots are intelligent and say, hey, there's a robot there. So you have to program it to determine what's there. Is there something coming? So what we've done with Spot with this customer is actually did a determination to do two things. One, let me know you, I'm going to let you know I'm coming. Flashing lights, beepers, things like that, the truck backing
music,
up.
right.
And two, when I get to the crosswalk, I'm basically going to look both ways before I cross. And it does that with its onboard imagery. So it does play nice with other robots if you tell it to.
Okay, great. Two more quick questions. I think they should be easy. I just want a yes or no. Is one, can Spot read a QR code? I think it's all dependent on what you have as the reading it, right, on the payload. So is that a yes?
Yes.
I mean, again, but based on the sensor. All right. And then the next one I think is good. It would be our last question. If there's more, we'll get them out to you. In the application where Spot is testing for gas or any other types of leaks, does that imply that Spot is rated for classified locations? And again, maybe it's what classifications does it meet, and how is that being handled if not?
Yeah, the quick answer to that question also is no. And the reason being is you talk about ATEX certification. One of the challenges of that is in order to be ATEX certified, you have to be stagnant. You have to be stopped. In other words, you cannot ever do any enhancements to this robot, right? So in that case, you render yourself, you purchase the robot, and there it is. It's going to be there forever.
Right.
There's also a lot of technology that needs to go into it. So what we do is we actually pull hot permits. Our customers actually pull hot permits because what we've done on the robot is actually have not exactly a kill switch, but when it detects certain levels of gas, it will shut down the motors. So it will basically sit down where it is. And that's when it has this type of detection. And with a hot permit, that allows compliance with that. So it's not ATEX certified, and I don't pretend it is. And I don't think we're ever going to be with this current robot because the actuators are exposed and things like that. But it does serve in that environment using hot permits and the kill switches.
Great answers. All right, well, that's all the time that we have today. Everybody out in that's joined us either live or on the recording, thanks for joining. Will, thanks for going through that demo. Very cool. Paul, thanks for the background. Nicholas, thanks for your industry expertise. And thanks to Spot. We have to say thanks to Spot. Oh, and Paul, thank you very much. I know that you got me Spot. So I haven't found out how to connect Scout into it yet. So Will, if you could call me so I can get that working. Again, if there's any information that you need, you can email any one of us. We'll send this out to you. Everybody, thanks for joining. We look forward to the next webinar that we have with you guys. Will, Paul, and Nicholas, thank you so much. Rachel, thanks for running it behind the scenes. Take care.
Thank you.